Hello everyone. We are going to begin our lecture on the first section of chapter 10, which is on percentages. Now I might as well mention that this is the only section that we will cover from chapter 10. From here we will go to a different chapter, all right? Now the word percent means per out of 100. So the word, this part per, means out of, and cent, as you can tell, is the word for 100. All right, now in English we don't use cent for 100 as such, but a lot of words that imply 100, like century and centenary, they represent 100. Century is 100 years, or centenary also means something similar. And the Latin word for 100 is centum. That's where it comes from. And many of the Romanesque languages, like uh, in Spanish, it's ciento, 100, or in Italian, it's cento, or in French, they spell it as cent, but they pronounce it as cent. But cent essentially represents the number 100. So when we say percent, we actually mean out of 100. And we commonly use, or we frequently use, or hear the word percent in during sales time, store sales, 30% off something, or 30% markdown, or 20% uh, discount, and so on, right? But there are many instances where we use the word percentage. So we will learn some applications of percentages and also how to work with percentages. All right. Now, the topics we will learn on percentages is to convert between a percent, a fraction, and a decimal number. So if a number is given to us as a fraction, we should be able to convert that as a percentage. Likewise, we should be able to convert a percentage value to a fraction, and the same with decimal numbers. All right. Then the next thing is to solve problems involving percent change. Then another area of application of percentages is problems involving percent markup and markdown. So if the price of an item goes up, it's called percentage markup. It goes up by 10%, then it's a markup increase. If an item is on sale, then it's marked down by a certain percentage. So we will learn how to solve problems of markup and markdown, and then some other percent problems as well. Okay. So let's define here what percentage means and also what it implies. So the word percent comes from the Latin per centum. So centum, as I said before, represents the number 100. It's the word for 100 in Latin, and it means per 100, and per means out of 100, out of 100. All right. And percentage is actually a ratio of some number to 100. All right. So the way we write the ratio is whatever that some number is goes in the numerator, and the per 100, because it's out of 100, that goes in the denominator. So when we are representing or writing a percentage in fractional form, then the denominator must always be 100. All right. And the percent value should be in the numerator. We use the symbol, this particular symbol, it's called the percentage symbol, to represent percentages. Instead of writing out the word percentage every time, we use this symbol to represent percentage. And when we write it using this symbol, then we do not need to divide by 100. 15% means implies it's 15 out of 100. So when I tell somebody that you scored 80% in a test, that means the test had a total point of 100. So out of 100, you scored an 80. All right, that's what 80% implies. Likewise here, 15% implies 15 out of 100. And so X over 100 means X%, right? So let's talk about how to change a fraction to a percentage. The first step is to divide the numerator by the denominator to obtain a decimal number. So a fraction will have a numerator and a denominator, of course. So let's look at this fraction here, 1 over 5. All right. So when we divide the numerator by the denominator, we will get a decimal value of 0.2. All right, 0.2. In the next step, what you do is you multiply the decimal number by 100, which has the effect of moving the decimal point 2 places to the right. So it's 0.2. In the second step, you take your 0.2 and you multiply it by 100. So 0.2 times 100 will give you 20, all right? And then you add the percentage symbol, right? So let's look at what the last step should be. It says in the third step, add a percent sign. So let's just quickly go over what we did. We took our fraction, which was given to us, 1/5, or which will be given to us in the case of problems, and then you first divide your numerator by the denominator. You will get a decimal value when you do that, and then in the second step you multiply your decimal value by 100, and then whatever value you get after that, you put a percentage symbol, percentage sign after it. All right. Let's go through these examples of converting fractions to percentages. The first fraction given to us is 67 over 100. Now, since it is already over 100, all you need to do is write it as 67%. All right. But if we were to follow the steps that we just learned in the previous slide, they said first divide your numerator by the denominator. When you do that, you will get a value of 0.67, and then in the next step you take your 0.67 and multiply by 100, which will give us 67, and you put the percentage symbol. However, whenever the denominator is 100, you don't need to do this division because you will end up with the same result. Just take your 67, just take your numerator and write it and put the percentage next to it. That's all. The next one is 11 over 20. So you can either use your calculator, take out your calculator, do the division first. 11 over 20 will give you a decimal value of 0.55, and then multiply 0.55 by 100. You will get 55, and then you add the percentage symbol. Now, another way of working this is just take 11 over 20 and multiply it by 100. All right, if we just multiply it by 100, what happens? 100 divided by 20 is 5, correct? 100 divided by 20 is a 5, and then you multiply 5 and 11, 55%. You get the same answer, right? So this is another way of working out percentage values from fractions. You first multiply by 100, multiply the fraction by 100, and then do the division. Then we have 15 over 16. Again, same process. You can either divide 15 by 16, get a decimal value, and then multiply by 100, or you can just simply multiply this by 100 and then do the division and add the percentage sign to the value you get. Now, I'm not going to work this out. You can do it yourself, or in the next slide, you will see the answers anyway. All right. So I'm going to go to the next slide. Converting fractions to percent. Again, they are giving us the solutions of the problems I worked out for you previously. 67 over 100. Let's see how they've worked it out. They divided 67 by 100 to get a decimal value of 0.67, and then 0.67 times 100 equals 67. So if you were to follow the step-by-step process that they gave us a couple of slides back, you can use that. But like I said, if your denominator is 100, then you do not need to do all this work. Just take your numerator and put a percentage next to it. Symbol, percentage symbol next to it. All right, so here they have the final answer, 67 over 100, which is the same thing as what we started with, equals 67%. So the next example was 11 over 20. So they first divided the numerator by the denominator to get a decimal value of 0.55, and then they multiplied it by 100 for a value of 55. And therefore 11 over 20, the fraction 11 over 20 in percentage value is 55%. All right. And then the other way I told you that you could work this is, instead of dividing first, you can just multiply 11 over 20 by 100 and do the division. So 100 divided by 20 is 5, right? So it gets 120 divide to give us value of 5, and then 11 times 5 is 55, and then you add the percentage sign next to it. All right, so this is another way of working it out. And finally, 15 over 16. Again, when you divide 15 by 16, you get a decimal value which is 0.9375. And then you multiply 0.9375 by 100. And when you multiply by 100, your decimal point shifts 2 places to the right. It will shift as many places as there are zeros in 100. All right, so it has 2 zeros, so you have to move your decimal point 2 places to the right, so it becomes 93.75, and then you just add your percentage sign next to it. So 15 over 16 is equal to 93.75%. To change a decimal number to a percent, we already did that in the previous examples when we are converting from a fraction to a percentage. Remember, when we were given a fraction, we had to do a division, we got a decimal number, and then we multiplied that by 100 to get the percentage value. Here, you don't, because it's already in decimal form, all you need to do is multiply the decimal value by 100 and add the percentage symbol. All right, so there are just 2 steps. First, multiply the decimal number by 100, and in the second step, just add a percentage sign. That's all there is to it. So let's look at some examples here to work on. The first one is 0.14. All you're doing is multiplying by 100, correct? To change this to percentage form. So when you multiply by 100, there are 2 zeros in 100. So your decimal point is going to shift 2 digits to the right. So it's going to be 14%. All right. So it's going to be 0.14 times 100 is 14, and you add the percentage symbol after that. The next one is 0.893. Again, multiply that by 100, and your decimal point will shift 2 digits to the right when you multiply by 100, and you'll get a value of 89.3, and then put the percent sign. 0.7625, multiply by 100, and decimal point shifts 2 digits to the right, So it'll go next to the right of 6. So your answer is going to be 76.25 and then the percentage symbol, right? So here are the solutions that Pearson provided to us. Let's quickly go over them and see if they match with our answers. So 0.14, again, they multiplied it by 100, added the percentage sign for a value of 14%. The next one is 0.893. They should multiply that by 100 and get a value of 89.3, and finally it was 0.7625 multiplied by 100 gives us 76.25%. Now, to change a percentage to a decimal number, we have to do the reverse of what we did when we converted from a decimal number to a percentage. If you recall, when we converted decimal to percentage, what did we do? We multiplied the decimal value by 100, right? So it's decimal multiplied by 100, which caused the the decimal point to shift 2 places to the right from where it was. When we are going the other way round, when we are converting from percentage to decimal, it's going to be the reverse. That means the multiplication is going to be a division by 100, and the decimal point is going to, this was the direction before, now it's going to move 2 digits to the left. All right, so let's go through the steps that are shown on this slide. So first it says remove the percent sign and then divide the number by 100 is what I said here. Divide the number by 100, and that will cause the decimal point to be shifted 2 places to the left. We'll now look at some examples of converting a percentage value to a decimal number. The first one says change 35% to a decimal number. All you have to do is take the value 35 and divide it by 100. All right. And when you divide 35 by 100, you end up with 0.35. So when you are doing division by 100, what happens is the decimal point in an integer value as 35, the decimal point, although it's not visible, the decimal point is to the right of the last digit 5. And when you're dividing by 100, it shifts to the left, 2 places to the left, and that's how we got 0.35, and that's 35% converted to a decimal number. The next one is 69.8. Same process. Take your 69.8 and then divide by 100, and when we do that, the decimal shifts 2 places to the left, so 0.698 is your answer. It's always good practice when a value starts with a decimal point, you should put a 0 before it. So 0.698. It's just good practice. If you write 0.698, it is correct. It's not wrong, but it's good practice to write it as 0.698. All textbooks will always write decimals in this form. 0. When a value starts with a decimal point, they will put a 0 before the dot, before the decimal point. The next one is change 0.5% to a decimal number. Now this is 0.5%. You can first convert the half to a decimal value and then divide by 100. So half is 0.5 divided by 100 will be 0.005, all right, in decimal. Or you can just do half. Instead of converting the half to a decimal, you can just take your half, divide by 100, and then that would mean half times 1 over 100, which is 1 over 200, and then you can do the division to get a value of 0.005. All right, so in the next slide, we will check our answers if we've done it correctly or not. All right. So the solution for 35% was, let's pull up their answers. 35 divided by 100 is 0.35. For the next one, it was 69.8%, which is 0.698. And then finally, there was the half percent. And the way they worked this out was they converted the half to decimal first, and then they divided the decimal by 100 to get a value of 0.005. Now we learn how to calculate percentage change in values. So the percent increase or decrease, or what is called the percent change over a period of time, is found by the following formula. So let me just give you a quick example of what percentage change would be. Let's say 10 years ago, the college tuition at a private school was $50,000. All right, let's say that 10 years ago, that is in 2014 or 2015, the college tuition at a particular private school was $50,000. And in 2025, it increased, it went up to $75,000. In this case, we want to know what was the percent change in the tuition. It went up from 50,000 to 75,000 in 10 years. All right. What was the percentage change? By how much percent did the tuition increase? So in those kinds of situation, we need to know how to calculate the percent change. And the formula, or the way you do the percentage change calculation, is, it's again a ratio, as you see. In the numerator, we have amount in the recent period or latest period minus amount in the previous period divided by amount in previous period, and then convert that to percentage. All right. So using this example, amount in latest period means recent period. All right. So more recent is 2025. So amount in latest period would be $75,000 minus in the previous period, that is 10 years back, what the tuition was. So that's 50,000 over, divided by amount in previous period. That means the 2015 tuition has to go in the denominator, so 50,000. All right, so we have to do this calculation. 75,000 minus 50,000 is 25,000 divided by 50,000. All right, 50,000. So that would be, it would be 25 divided by 50. Therefore, it would be 0.5. All right, 0.5 multiplied by 100. Multiplied by 100. So it went up by 50%. All right, so this is how we are going to calculate percent change. The recent amount minus the previous amount over the previous amount, and then you just convert that to percentage by multiplying by 100. Now, percent change doesn't always mean that the change has increased. It's an increase in the percentage. No, it can also be a case where the value in the recent period has come down from what it was in a previous period. So if that is the case, then we talk about percent as a percent decrease. When it increases, as we discussed in the example of college tuition going up, it's a percent increase. So let's go over this slide here. It says if the amount in the latest period is greater than the amount in the previous period, which it was in the example of college tuition, right? The latest period uh, tuition was higher than the tuition in the 10 years back. In 10 years back, the answer will be positive and indicate a percent increase. If, on the other hand, the amount in the latest period is smaller than the amount in the previous period, the answer will be negative and indicate a percent decrease, right? So let's work out a problem on percent increase. Let's read the problem first. In 2014, the Major League Baseball team with the most improved record for winning games was the Los Angeles Angels. In 2013, the Angels won 78 games. In 2014, the Angels won 98 games. Determine the percent increase in the number of games won by the Angels from 2013 to 2014. So the recent period is 2014, in which they won 98 games, and in the previous year they won 78 games. So this is a case of percent increase because the games won went up from what it was before. So we are going to use the same formula that we learned. It's previous minus it's recent minus previous. All right, let me write that down here. It's recent minus previous over previous over previous. And then we convert that, whatever decimal value we get from here, we convert that to percentage by multiplying it by 100. So let's see what they do here, but just note the data. 2014 was 98 games, and in 2013 it was 78 games. So we essentially have to remember 98 and 78, which will appear in the next slide. All right, so here it says they're working out the solution. Percent change is calculated by the formula amount in latest period, that is the recent period, minus previous period over previous period. All right, so 98 was the recent number of games won recently, minus 78 was won in the previous period, in the previous year, divided by 78. And when you do this calculation and multiply by 100, 98 minus 78 is 20, right? So 20 divided by 78 times 100 gives us 0.2564. You have to multiply that by 100 to get a value of 25.6%. So their percent increase in the number of games they won was 25.6%. Okay. Now, another area where percentages are used is in the area of profit and loss. And sometimes we call that percent markup or percent markdown. All right. So there's a formula to calculate the percent markup. Markup means you are selling an item at a higher price than what you purchased it for. So, for example, if you purchased a house for $100,000 and then 10 years later you want to sell it, but you made some investments on it, you made some improvements on the house and spent another $20,000, and you want to make some more profit. So you purchased it at 100,000, but with all the improvements you made and some some profit that you want to make from that house. You want to sell it at $150,000, right? So that is a markup. When you sell it at a higher price than what you bought it for, is considered to be a markup. The markdown is the opposite of that. So if you purchase something and you sell it, maybe it depreciated. Cars often depreciate, right? After you buy it or over the years. So if you purchase a car for I don't know, $50,000, and then after 10 years its price depreciates, you can only get maybe um, $20,000 for that car. So you have to sell it at a lower price than what you bought it for. That's a markdown. All right. So even when stores put up a sale, they it's considered a markdown. When they give you a discount on a price, it's a markdown. All right. So that's what markup and markdowns are about. Now, when the answer is positive, it indicates a markup. That means you made a profit. All right. In a markup, you make a profit. The answer is positive. A negative answer indicates a markdown. So percent markup or markdown on cost is calculated using this formula. So selling price, all right, selling price minus the dealer's cost. So what you sell an item for minus what you bought it for, divided by the by your by the price you bought, so dealer's cost. So selling price minus cost price over cost price, and then you multiply by 100 to make it or write it in percentage form. All right, so that's what percent markup is about. Now here's an example on determining percent markups. So I'm going to read through the problem and then we are going to solve it over the next few slides. So it says here, Holdren hardware stores pay $48.76 for glass fireplace screens. They regularly sell them for $79.88. At a sale, they sell them for $69.99. So the question we need to answer is determine the percent markup on the regular price, and then part B is to determine the percent markup on the sale price. So let's just stay here a little bit and try to understand the problem. Now we said that the percent markup, there's a formula for it that we saw in the previous slide, and that was the selling price, and I'll call that SP, minus the cost price divided by the cost price, and then to find the percentage, you multiply it by 100%. All right, and that's the percent markup or the markdown. It could also be marked down if the answer is negative. All right, so let's try to understand what would be the selling price versus what would be the cost price for this problem. All right, so the hardware stores, they pay $48.76 for the item when they purchase it and bring it to their store to sell it as a retail. All right, so $48.76 is their cost price, is what they purchase the screens for, right? And then this, it says they regularly sell them for $79.88. So they sell them for $79.88. That's the selling price. All right, so here's our cost price, $48.76, and the selling price is $79.88. That's the selling price. However, at a sale, they sell them for $69.99. a price lower than 79.88, right? Otherwise it's not a sale. They give them a discount. They give their customers a discount. So 69.99 is also a selling price. This is also a selling price. So when answering part A, we will have to use the regular price, which is 79.88 for the selling price, and for part B, the sale price. To find the percent markup on the sale price, we have to use the 69.99, and for both, or in both cases, the cost price is going to be the same. All right. So here we are solving the problem, part A of the problem, really. So again, the formula was SP, the selling price. It was selling price minus cost price over cost price. So here we have the selling price 79.88 and the cost price is 48.76, and we subtract them, and over here in the denominator we again have the cost price and then multiply by 100. It's as simple as that. All you need to do is identify which one is the selling price, which one is the cost price, and plug them into the formula and do the calculation. So this part of the calculation, 79.88 minus 48.76 divided by 48.76 approximately is 0.6382, and then once we multiply it by 100, 63.8% is the answer. So that means they are making a profit of 63.8%. That means they have increased the price from by 63.8% on their cost price. All right. Now part B of the question was asking the percent markup on the sale price, correct? So the sale price was 69.99. So again, same formula is being used, except that instead of 78 something, we are now plugging in 69.99, which was the sale price. The previous part was on the markup on the regular price, selling price. So 69.99 minus 48.76 divided by 48.76 is 0.4354, and then once you multiply it by 100 you get a value of 43.5%. So here the markup is 43.5. So it's a lower markup than when they were selling it at their regular price. All right. Now this is another application problem of percentages. It says here it's on the down payment on a condominium home. So Melissa wishes to buy a condominium home for 189,000. To obtain the mortgage loan, she must pay 20% of the selling price as a down payment. Determine the amount of Melissa's down payment. In other words, we have to calculate what is 20%, what amount is 20% of 189,000. All right. So this is a pretty straightforward problem. All you have to do is calculate, convert 20% to decimal value and multiply it by 189,000 to get the amount of the down payment. So let's go on to the next slide to see how we go about solving it. So here you go. First they write it as x equals the value that we have to find. The answer that we have to give is what is 20% of the selling price, and the selling price was 189,000. So they converted 20% to 0.20 by dividing it by 100, and they multiplied it by 189,000 to get a value of 37,000 $800, and that is the down payment that Melissa will have to pay. All right. So this concludes the topic on percentages. From here on, we are going to now go to discussing a bit of geometry topics on geometry. All right.